Okay, today we're going to start our next chapter, and it's on rational functions, and today we're going to look at what a rational function is and do some transformations on those graphs. So to start, what we're going to look at is what a rational function is. So first off, it is a fraction where the top and bottom could be polynomials. So it could be anything like x plus 1 over x minus 2. That would be a rational function. We could get one that's something like 1 over x plus 1, or you could even get 1 over x, or a rational function is actually something just like 4, y equals 4, because we could write that as over 1. So basically any kind of fraction of polynomials is what we're dealing with. Our typical or our base fraction that we're going to look at is y equals 1 over x. So we have it a bit of a different case where x now is on the bottom, so that means we have a non-permissible value. So in this case, x can't be 0. So what happens in this case is at 0 we get an asymptote line. So we have an asymptote line at x equals 0, and if we actually graph y equals 1 over x, we get a graph that looks something like this. What we do see is we also get a horizontal asymptote line, and it's showing up at y equals 0. And the other key points that we can see here is when x is 1 or negative 1, because when we go 1 over 1, that's still equal to 1, or 1 over negative 1, those are equal to negative 1 as well. So if we were to graph y equals x, we would get basically a diagonal line, something like that, and you'd see that these 1 and negative 1s are invariant points. So when we do kind of the 1 over of this graph, we end up getting these weird sort of curve shapes. So what we want to do is basically be able to graph this and understand how the graphs work pretty quickly. So first off, let's look at this one. So now we've got y equals 4 over x. We could do a table of values. So you could do things like when x is 0, 4 divided by 0 doesn't work, so we have our asymptote line. When x is 1, we'd have 4 divided by 1, which would be 4. When x is 2, 4 divided by 2 would be 2. When x is 4, we could get 1, and so on. So we can see our graph would do something like that. And we could do the same thing in the negative direction. 4 divided by negative 1 would be at negative 4. Made a mistake there. And 4 divided by negative 2 would be negative 2, and so on. So we'd get a matching graph going in that direction. So a couple of key things we want to be aware of is what are our characteristics. So we have our asymptote lines at x equals 0 and y equals 0. That's our two horizontal and vertical asymptote lines. And we also see that we have no x or y intercepts. And the 1 and 4, that coordinate, and the other one would be at negative 1, negative 4. Those are important coordinates because it's actually going to tell us what that vertical stretch is. So our normal graph should be at 1, 1. In this case, it's at 1, 4, so we're getting 4 times taller. So that leads us into transformations. So when we're dealing with transformations, just like before, our A number, or our front number, is our vertical stretch. So you can see that we have our A of 3 in this case, so we have 3 times taller. And our H is our horizontal. So that means we're going 4. So we're going 4 to the left. And we can see our K is 5. So we went 5 up. So what we want to do with this, we know that in a normal graph, our asymptote lines should be at the 0 and 0 location. So what you want to do is move those as your transformation. So we want to move the asymptote line 5 up. And move the vertical asymptote 4 to the left. So that gives us our new locations of asymptotes. And now our 3 value, or A value of 3, is we'll go 1 over, like normally we'd go 1 over and 3 up, but we'll do that from our new intersection point. So go 1 over and 3 up is there, 1 over and 3 down is there. And then usually from that we can kind of get a pretty good sketch of what our graph's going to look like. Okay, so let's kind of go through this again. So we can see here we've got 4 up, so at y equals 4 will be a horizontal asymptote. We got 3 to the right, so that'll be our vertical. And a 2, so go 1 over and 2 up, 1 over and 2 down. And we can pretty much just sketch our graph based on that. If you wanted to get it a little bit more accurate, like I said, you could plug in a different x value, plug in x of 3, 4, 5, whatever. and you'd get those other points. So there's our graph. We have our non-permissible values. That's basically our asymptote lines. So in this case, we say x can't equal 3. So our domain ends up being x can't be 3, and our asymptote line is at x equals 3. In terms of the y direction, we say y can't equal 4. So our range ends up being y can't equal 4, and our asymptote line is at y equals 4. Our x and y intercepts do show up now. Like normally we wouldn't have any, but because we moved it up and over, we do see we have an x-intercept and a y-intercept in this case. And the easiest thing with these ones would be either just plug in the zeros in the equation and solve, or just graph it and find your x and y-intercepts that way. It should work either way. Okay, so the last thing we got to look at is how do we convert an equation to get it into our transformation form. So if we look at this one, we could graph it the way it is, but it doesn't really help us to figure out what our values are. So what we want to do is we want to first change the equation. So we have 3 on top, ready to... Okay, so you want to change the top, keep that 3 separate because that's going to be our A value. And then what you want to do is change the top and the bottom to be the same, because our whole goal is to be able to cancel that factor out, that x minus 4 factor. So if we change it to that, we can see if we actually were to FOIL this out, on top we'd have 3 times x, 3 times minus 4. So it gives us 3x minus 12. So that's close to what we have. We have 3x plus 6. So we got to make sure that we're not changing the question. We're just trying to rewrite it in a different way. So what we have to do then is add on a number that's going to be still equal to positive 6. So if this gives us negative 12, we want a positive 6. We're actually going to have to add on 18. So our fraction would end up being that, but then we're going to actually rewrite this a little bit differently. We're going to write it as 3x minus 4, and we're going to write the 18 separately over x minus 4. And then now we can see we can cancel the x minus 4's. So our equation ends up becoming, and I'm going to rewrite it in the other order, so we'll have 18 over x minus 4 plus 3. So now we can see by looking at this equation, we have it in our transformation form. So our A is 18, our H is 4, and our K is 3. So we know our asymptotes are 4 to the right, 3 up, and our vertical stretch would be 18 in this case. Okay, so let's do one more kind of like it, and we'll draw the graph. So let's convert this one. So we want to take that 4 out, and we want the top to be x minus 1. So 4x minus 1, if we FOIL that out, we'd have 4x minus 4. We want it to be plus 2, so that means we've got to add on a 6. So 4x minus 4 plus 6 would give us the plus 2. Now we can kind of cancel those out. So we'd end up getting 4 plus 6 over x minus 1. And we can rewrite it the other direction if we want. And we're good to go. So now we know our asymptote line's at 1. And our horizontal one would be at positive 4. And we have an A value of 6. So go 1 over and 6 up. And then go 1 over and 6 down. And we can draw our graphs from there. And that's good enough. So that's it for this topic, and we'll continue with this in our next section when we look at more specifically at asymptote lines.